Hello and welcome to day 8. Today we have a state transition problem. Basically we're given a list of instructions and a list of states. We're going to start in A and we want to go through and find out how many steps it takes us to get to stage Z. So from A we'll take the right value, which is C, and then from C we'll take the left value, which is Z, and we're done in 2 steps. If we run out of input, then we basically just rotate back to the beginning. So from A, we'll take a left to B, and then from B, we'll take a left to A again, and then from A, we'll take a right back to B. Now we're out of input, so we start back over from the beginning. So left takes us back to A, left takes us back to B, and then now right takes us to Z, so we've used 6 steps, and that's our answer. Of course, in these things, the first thing I do is take in our inputs, so I made a new data class for node that just takes in name, left, and right. Our instructions get pulled in for the first line, and the rest of the lines we just split them up and add them to our node class like usual. Then we'll go through here. We'll start at our current node at the head node A, and our steps at 0. And while our current node is not the end node, we're going to reset the current node based off of which direction we need. And the directions, we're just going to use a modulo on the steps. That way we don't have to keep track of 2 variables. Whenever steps runs off the edge, we'll just circle back to the beginning. And if that's a left, we'll take the left node. If it's a right, we'll take the right node, assign it to the current, we're done. And then once we actually hit the Z node, we return steps, and that's our answer. Pretty simple. For part 2, of course, things either always get more complicated or add more instructions, or they get more difficult to compute, and that's the case today. So what's going to happen is, instead of starting at a single node of AAA, we want to start simultaneously in all nodes that end with an A, and then we want to continue to go until we hit all nodes that simultaneously end at a Z. So to start with, we'll start at both 11A and 22A, and then we'll go left on both of them to 11B and 22B, and then we'll go right on both of them, so on. Now, this doesn't sound too like it's really that much worse, and like looking at my input, there was I think 6 starting nodes, and there's about 780 total nodes. So that doesn't seem so bad, right? But if we actually look at it, the problem is if I have like 780 nodes for the first option, right, and I have 780 nodes for the second option, and I have 780 nodes for the third option, and I have 780 nodes for the fourth, and the fifth, and the sixth, you can see that the number of states gets kind of large pretty quickly. So obviously we have to do something that's a bit smarter than this. And basically what ended up doing, so what you want to do in these cases is you want to find loops, because there's only like a finite number of instructions left and right, which is like 260 or something like that, and there's only a finite number of states. So somewhere in there, every part of it has to loop. But the problem is they don't loop at the same rate. Today's is actually a bit simpler than that. The instructions don't really specify it, but playing around with the data actually makes it, or kind of shows that simpler. So let me just do that real quick. Hang on. Okay, so basically I just printed out every time the initial one, the AAA, hits ZZZ. So, and we'll just keep repeating over and over. So the first time it hits it on mine is this, and then the second time, third time, fourth time, so on. Now, if we look at that, so 18673 times 2 is the second one, right? 18673 times 3 is the third one, right? And so it hits this loop immediately, and the loop is always starting back over after the initial state. That was not necessarily a guarantee the way the problem is worded, but because of the particular data they gave us, that loop doesn't have any buffer beforehand, and it doesn't change size later. So like you could imagine where the last element drops us in the 5th spot of the loop or something like that. So you'd have 5 extra the first time, and all remaining portions of the loop you have the same number minus 5, right? But that's not the case of what they gave us. So That makes it easier because we don't have to try to find where the loop is or anything like that, and we don't have to try to do all the math on that portion. What we do need to do is get all of those the loop links basically. So I'm going to just grab our starters as a filter where the last letter is an A, and then for each of our starters I'm going to do exactly the same thing we did before in part 1 and turn that into a list, which is our list of first Z locations. Then I'm going to find the least common multiple of the first of each of these first Z's. So like least common multiple is, I'll just take like say 20 and 30, right? So like the least common multiple of those is going to be 60. So that's the first number that is divisible by both 20 and by 30. In this case, we don't want a number that's just divisible by two numbers. We want them divisible by all 6, and these 6 numbers are fairly large. So large enough that you definitely need to change to a long for today, and that should be good. If you are having problems with that, what I would suggest doing right now is leave it as int. Just find all of them, print them all out individually, and then go online to, just go to Google for least common multiple calculator, throw your numbers into there, and let somebody else do the work, and that should get you good for the day. This is good, definitely a good thing to add to your code though. You'll use this at least one problem a year seems to use the least common multiple, so it's a good problem to have. Anyway, other than that, if you have any questions or comments, hit me up in the comments below. If you want to check the codes on the GitHub, of course, and I will see you tomorrow.